All right, so we have established that there are three potential risk attitudes that consumers might have. They might be risk neutral, might be risk averse, might be risk preferers. We figured out that risk neutral consumers are fine with risk. They're not willing to pay to get rid of it. Risk averse consumers prefer not to have risk, and they'd be willing to pay to get rid of their risk. They'd be willing to purchase insurance that would, in exchange for getting rid of the risk. And risk preferers are not interested in buying insurance. But what we want to do is to figure out, would a risk preferer be willing to sell insurance to someone who's risk averse? And is that one way for an insurance market potentially to be organized? So we're going to start with that question, and then we'll move on and look at a different potential way of organizing an insurance market. So, so let's start by assuming that we have a risk-averse consumer who's interested in purchasing insurance, and then we'll figure out whether the risk preferer will sell it to them. So we have a risk-averse consumer, and let's suppose then that their utility is just the square root of x. Okay, and X is their income. They expect to have an income of $100, but the reality is that sometimes their income is less, it's $50. And the probability of having that reduction is 20%. The probability that they get to keep their entire $100 income is 0.8. So let's see, first of all, what the expected value of their income is. 20% of 50 is 10, plus 80 is, the expected value of X then is $90. That's on average what their income will be. And what's the expected utility? Well, find the utility, take the square root of 50, 7.07, square root of 100 is 10, and now weight these by the probabilities. 7.07 times 0.2 is 1.41. 10 times 0.8 is 8. And so we find that the expected utility is 9.41. And we can draw a picture of this situation. So utility, value of X, and nice looking utility function here. Maybe it looks something like that. So this is utility square root of X. And what we know is that the value of income could be $100, and sometimes the value is reduced to $50. When the value of the income is $100, the utility is 10, and then when the value of the income is $50, the value of the utility is 7.07. And to find the expected utility, we need to connect these points. We know that the expected value of income is $90. And so on average, the income is 90, and that gives us an average expected utility of 9.41. So this consumer, because they face this, because they're risk averse and they face this uncertain income, the utility that they get, the expected utility they get is less than the maximum amount they're hoping for. So one question we can ask then is, how much would this person be willing to pay to get rid of this uncertainty that they face? And to find the answer, we take this value, 9.41, the expected utility, and we square it. And that gives us 88.54. And what that's showing us, that 88.54 is going to come up right about here. So that's 88.54. And what that says is that if this consumer had an asset or an income of 88.54 all the time, then they would get a utility of 9.41 all the time. And they would prefer that, or they'd like to have that rather than risk sometimes having a utility of 7.07. And so this distance right here between the starting value and the value of the asset that gives a certain utility of 9.41, this shows the maximum willingness to pay for this consumer, and that distance is 11.46, or $11.46 is the maximum amount this consumer would be willing to pay to purchase insurance, $50 worth of insurance. If they pay this $11.46, then their income, let's say with insurance, the income would be, well, in the case where they have a $50 income, they've suffered this loss of $50. And so they have their $50 income, plus the insurance policy will pay them $50 to restore their original income, minus they have to pay the premium, which we'll call pi. In the case where they don't have a loss, then they have their $100 income minus their premium. And so this is 100 minus the premium. This is 100 minus the premium. And what you can see is that in either case, whether there's a loss or no loss, this consumer with insurance ends up in exactly the same place. And the value of their income is $100, the starting point, minus the premium. And we've shown that the maximum premium they're willing to pay is $11.46. So that establishes that the maximum the risk-averse consumer would pay is $11.46. So the maximum willingness to pay is $11.46. Now let's talk about the risk preferrer. And this risk preferrer, we'll say again, has utility function of x squared. Or you know what, let's, just so we draw a distinction, we'll call the risk preferred's income y instead of x, just so we can establish the distinction between the two. And this risk preferrer, let's just assume, to make our life a little bit simpler, that they have a certain income of $100. Okay, so y equals 100 all the time, and that means the utility that they get from having an income of 100 is 10,000. Okay, and so this risk preferrer has a certain utility of 10,000. All right, now the question is, will this risk preferrer sell insurance? Well, in order for them to sell insurance, they have to be at least as well off with insurance as with that. Sorry, that shouldn't be $10,000. It's really 10,000 utils, isn't it? So I'm going to get rid of that with magic. All right, so the utility is 10,000 utils. All right, so in order to sell insurance, the risk preferrer must end up with utility greater than or equal to 10,000, right? Because they get utility of 10,000 if they do nothing. They must be better off selling insurance than not. So let's think about this. If the risk-averse consumer suffers a loss, then this consumer will take their $100, pay out $50 to the risk-averse consumer, but they'll also collect a premium. If there's no loss, then the risk preferrer, the insurer, keeps their $100 and the premium. And the probabilities associated with that are 0.2 and 0.8. Okay. So what's the expected utility for the risk preferrer? Well, let's do it this way. The risk preferrer is going to have an income of 100 plus the premium. The utility is that squared, and that happens 80% of the time, plus 50 plus the premium. That's this case. The utility is that squared, and that happens 20% of the time. Okay, so these are the two cases for the risk preferrer, and this is the expected utility then for the risk preferrer, and we're going to say that that has to be greater than or equal to 10,000. So now what we need to do is to figure out what value of pi, what premium makes the selling of insurance, makes the expected utility greater than 10,000. So we just need to expand this. So this is going to be 10,000 plus 200 pi plus pi squared times 0.8 plus 2,500 plus 100 pi plus pi squared times 0.2, and that's got to be greater than or equal to 10,000. So that's 8,000 plus 160 pi plus 0.8 pi squared plus 0.2 times 2,500 is 500 plus 20 pi plus 0.2 pi squared. That's got to be greater than or equal to 10,000. So let's see, that's 7,500 plus 180 pi plus pi squared has got to be greater than or equal to 10,000. And so that's going to be, just sort of rearranging this, pi squared plus 180 pi minus 2,500 has got to be greater than or equal to 0. And so this is a quadratic equation. We can use the quadratic equation or the quadratic formula to solve this. When we do, we will find that pi has one of two values, either 7.98 or negative 187.98. A negative premium doesn't make any sense in our case, so we simply eliminate that and say this must be the minimum premium that is acceptable. So $7.98 is the minimum premium to sell the policy. Okay. Does that actually work out? Well, let's take a look. The income is either going to be $57.98, and the probability of that is 0.2, or $107.98 with a probability of 0.8. And right, so that's what's going to be with the insurance policy at a price of $7.98. If you work through this, you will find that the expected utility is $10,000. And so that is, in fact, the premium, $7.98, that makes the risk prefer, leaves the risk prefer in the same situation they would be as with the certain income. So any premium greater than this is going to lift their utility, their expected utility, above 10,000. So they'd be better off with a premium greater than $7.98, but $7.98 is the minimum amount they're willing to sell a policy for. So $7.98 is their minimum price. The risk averse consumer is willing to pay up to $11.46 for this policy. And so it looks like it's possible for this to happen, that this consumer is willing to pay more than the minimum amount the risk preferer wants to charge in order to make the policy happen. What's the downside of this? The downside of having risk preferers be the insurers for risk-averse consumers. Well, the downside is you need a lot of risk preferers. And our experience tells us that most people are more likely to be risk-averse than risk preferers. And trying to match up risk-averse consumers, people who want to buy insurance, with risk preferers who are willing to sell it, turns out to be a very difficult thing to do. And so while this is one way to think about insurance, it turns out not to be a particularly practical way. All right, we'll come back in a second and talk about a different way to provide insurance.